Ladies and gentlemen, please welcome Shane Wall.
Welcome, and thank you very much for that warm welcome. As the Chief Technology Officer for Printing and Personal Systems, I think I have probably the best job in HP. And the reason I think that is I actually have the opportunity to lead a team of futurists, strategists, technologists, product people in really defining where we're going in the future. And so it's in that vein I want to share with you a little bit of what we've been doing the past year, and in particular, share our vision about blended reality. But before I get into blended reality, what I want to do is actually start with how we look at things, how we approach things within printing and personal systems, how we look at the future. And it always starts with people. It starts with mega trends. It starts with those things that are going on in the world around us that may not necessarily be technology, but they influence the technology direction that we set. And so there are some of these things as examples. It's a changing population. We'll soon have about 8 billion people on the planet. And the demographics of those people are changing. We're watching wealth move to the emerging market. We're watching an aging, mature market population. We're seeing entire generations growing up where technology is a root, where it's already in their being. They seem to come out of the womb and they already have an iPhone. I mean, how else could we have this many phones in the world? But it's not only this, it's the trends that are happening, that have happened really for the last 150 years in manufacturing. The Industrial Revolution that remade our society, and we think we're on the cusp of what will be the next Industrial Revolution, and I'm going to share with you why we think that. But it's not only the manufacturing things, it is the collaboration. It's that social awareness. It's that connection that we like to create with people. And we've done it through a set of technologies, and we think we're on the cusp of some new things going forward here as well. And then finally, it's tapping into those things that people have done for many, many years, certainly for several thousand years, which is the ability to make. And they've done those things in very natural ways. And what we've come up with is a way to take those natural ways of them doing making and put it in easy-to-use technology pieces. And I want to talk to you about that today. So, the constant in all of this is really change. And so how do we make sense of this within printing and personal systems? The way we make sense of it is we've actually created 5 pillars, and these become the nature of our work within printing and personal systems. This is how we lay out our roadmaps. This is how we lay out our future and our product definitions, and there are really 5. One is hypermobility, and that is to move everything to mobile. We have it today in phones. We have it in tablets. It's going to move to the wearables. It's the watch that we introduced about 2 months ago, but it's going to move into ingestibles, into embeddables, into things that are actually you're going to wear and it'll be on you. It's immersive and contextual experiences, moving to a more natural environment where it's not, click and tap, but to where you can actually interact in a very, very natural way. It's the Internet of Things. It's how not only connecting people, which we've done today, but how we connect the billions of objects and we use them to our advantage in order to automate our world or tell us more about our world. It's the 3D transformation. Now, this is typically we look at as 3D printing, and that's certainly very important, but I'm here to tell you there's a bigger opportunity, there's a bigger transformation going on, and it is around the next industrial revolution. And then finally, it's around smart machines, and that is how things like robots, drones become smart assistants for us. All 5 of these areas are ones that we're investing in printing and personal systems, or ones you'll watch us come out with here over the next several years. What I want to delve into are 2 in particular: immersive experiences and 3D transformation. And when taken together, we have created a whole new vision that we call blended reality. And it's very simple. It's how do you empower people to create, interact, and inspire like they never have before. Very simple notion of today we work in a physical world. We want to be able to take physical objects, and then we want to be able to pull them in a natural way into a digital system. We want to interact with them in that digital system just like we would with the object itself. We want to be able to edit it, change it, colorize it, make it ours, protect it, publish it up so somebody else can take it, and then turn around and print it back out, manufacture it. That is blended reality. Now, to give you a little bit of sense of what we mean by that, let's take a look at this video showing our vision.
All around us, technology is changing things. It's enhancing the way we live, work, and play. But sometimes, the experience falls short. We live in 3D, yet technology lives in 2D. So when we want to create, we hit barriers. Our imaginations are limited to clicks and taps. We believe technology can be humanized. It can close the gap to blend the physical with the digital, enabling us to create with the tools we were born with. Or we can grab something, mash something, and make something even better. This is the vision and the promise we call blended reality. And with it, we're reimagining a whole new world of possibilities.
So this is blended reality, and it really constitutes two main areas of thrust for us. On the front end of this is how do we make it a simpler interface? How do we make it easier for people to manipulate physical objects? And here the focus is on immersive experiences, and it's really bringing out the maker in all of us. Today, a large percentage of the population would consider themselves a maker in some way. It could be simple crafting, it could be the things that you do in a garage, or it could be much more advanced things. But really what it is putting three pieces together. The creativity, the desire to solve a problem, the willingness to tinker and change and do something different, and then what's missing is the simple tools in order to make it happen. And this is where the first half of immersive experiences and blended reality comes in, and that is in the form of Sprout. So Sprout is our product we introduced about a month ago that focuses on solving that upfront immersive experience issue. It blends a set of technologies that are common today, the scanner, the projector, the camera itself, but it does it in a unique way that creates a total experience. Let's look at that experience. So this is Sprout. If you haven't seen it or played with it, there is one out here in the hallway. Stop by, take a look, you get a chance to actually do a little bit of what you see in that video. But what I would emphasize is, don't look at that as a point product. Our vision is much bigger than that, and what we look at this is a whole new compute platform. One that is starting in consumer and will start with the maker at home or the simple creative person who wants to do something different. But we intend to grow that and push it up into the commercial segment where we can do it in a much more professional setting, but still retain that interactive, sort of creative focus. And we'll push it into our mobile products, where you'll be able to do some subset of these activities on a mobile device itself. So, a platform overall. So that's the front half of blended reality. Now let's switch and talk a little bit about what's the back half of blended reality. And the simple version of that is being able to take that which you created, now maybe it's something simple at home today, but ultimately becomes something much more complex that a professional would have created in an AutoCAD or some other application, and then be able to take it and print it out instantly. And where we see this opportunity is truly revolutionizing manufacturing. We see it as the next industrial revolution. And if you think about it, for the last 150 years, the focus of our society has been, how do I optimize this manufacturing? How do I take material in? How do I stage it, make sure it arrives at the right time, then turn around and make it in a large manufacturing assembly line? Maybe it's people, maybe it's robots, but how do I optimize that? And then how do I stage it? How do I stage it in distribution centers, retails, and the like? And it doesn't matter whether you were making toys or complex cars or what, the winner is the person who could do that the most efficiently. We think that is going to change, and it's going to change radically with some of the 3D print technology we're going to come out with. And so what I want to do is talk to you about that technology and what we have. At the heart of our technology, really, if you look at 3D printing today, and probably what inhibits its adoption, are four things: speed, quality, economics, and innovation. All four of these we radically address with multi-jet fusion technology. So let me show you a little bit about how we do that. Today, in 3D printing, there are three main technologies. Okay? There's material extrusion, there is laser sintering, okay, and then there's our recently introduced multi-jet fusion. So the way they work, I'll give you the basic tutorial. The one on the left is material extrusion. Really, it's a glue gun on an XY table. It melts a set of plastic material, and then it does it in a very fine drop. It traces a level across, and it does it in a very serial fashion. You want it to go faster, make a bigger drop, quality goes down. You want it to look better, make a finer drop, it gets even slower than what you see here today. This is the technology that's used today in most of our consumer 3D printing. Step up a notch and we move to laser sintering. Laser sintering has better quality in terms of the types of material it can produce, and it goes faster. It's basically a laser that scans across a set of material, powder material that's laid down on a base, and the laser burns the material and fuses it at that position. And then it does it in a serial fashion back and forth. So by tracing across the whole line, you can create the outline of one layer of the gear here. Now, it gives you improved property capabilities, but it suffers from being slow. Enter multi-jet fusion. Completely radical, different approach to solve this problem. It has three simple passes. Lay down a set of powder material, fire a set of liquid, which we'll talk about the properties of that, over it, and then come back a third time and fuse it. And so you can imagine the speed gains that comes from this. It is not a serial process of tracking something. It is doing everything in one layer. And so here you get a sense of exactly the speed that comes from this. You're now talking about 10 times the speed of the fastest machines today. Now that's not all. We said we would improve the overall quality of the parts. And we do that through the core technology. The way our technology works is after you lay down a layer of powder, you take our print bar, which is the multi-jet fusion technology, and we have the ability to fire 320 million drops per second. And those drops can have very unique properties. And we can place them at about 20 micron accuracy. So now I can take a drop, and I'll show you the properties, and I can put it on a layer here in order to change the properties. One thing I can change is color, which cannot be done today, or it's very difficult to do it today. You fire the individual drop, you add the color into the drop itself, you do it on a layer, you build those layers up, those layers then come together, and you end up with a part that can be completely colorized and customized in a way that you'd like. So today, you can always do, all courtesy of us and our work in the printing side, you can print out all sorts of stuff, coffee cups and the cubes and the like. Well, now we have the ability to print the device and put the photo in it. Totally revolutionary on how we'll do it. Now, we don't stop at color. We actually have the ability to modify the properties of the material itself. So now we can do things like, well, we already mentioned the ability to colorize an object, but now we can go change things like surface properties. We can make it rougher, we can make it smoother. We can change the translucency, so we can make it solid or we can make it transparent. We can change the elasticity and strength, so we can have a strong part or we can have a flexible part. We can change the electrical conductivity. We can print electronics. And finally, we have the ability to print advanced materials. So in the future, we'll obviously do plastics, but we'll add into it ceramics, we'll add into it metals, we'll add into it a set of things that allow you to change the overall and do advanced materials in here. So when you put all of this together, and now you have the ability to create very unique parts, and I want to come back to one aspect I mentioned. Not only can I create unique material in those parts, but I can change the electrical conductivity, which means I can print electronics in the parts themselves. So now I can have functional parts that actually perform an electrical duty. So now imagine in the future, think 5, 10 years down the road, what we're able to do. Let's take a look at this vision.
HP's 3D printing technology enables the world to realize the full potential of 3D printing in fully functional parts. HP functional agents could control texture, friction, strength, elasticity, electrical properties, thermal properties, and more. Imagine a single part with stiffness optimized in some areas, elasticity in others, or wear resistance and friction customized where needed. Or imagine printing a complete electromechanical module in a single 3D build without requiring further assembly. The list of future possibilities seems endless.
Okay, so I don't want to leave you the impression we're going to go print an animal and it will suddenly come to life. But what I do want to leave you with is we have the ability to create very advanced mechanical and electrical structures, which essentially we have the ability to manufacture. So we come back and pull it together of what we're trying to do with blended reality. And with blended reality, we're trying to simplify that front end, make it easy for anybody to be a maker, to be a creator, and then to simplify even for the professionals that creation activity. And then be able to take your creation and print it out in a functional part. So I said at the very beginning that I thought I had the greatest job ever. And that was as the CTO and lead a tremendous number of very talented individuals. And I will tell you, when I was a little kid, I always knew I wanted to be an engineer. From the time I was, as my mom used to say, knee-high to a grasshopper, is I always wanted to be an engineer. And the reason I wanted to be an engineer was because everything was possible when I was a kid. I could think of everything that was possible. And now, I think with the innovation we're bringing to printing and personal systems and our vision of blended reality, we really can make some of these dreams come true. Thank you very much. If you want to learn a little bit more, if you'd like to learn a little bit more, you got a few references here. There is a sprout outside you can take a look at as well. So thank you again.
Ladies and gentlemen, at this time we ask that you complete your survey. Hand any paper survey to the host or hostess as you exit the theater. Thank you.